All right, we're interested in converting the Cartesian coordinates negative 2, 6, so they're xy values, to polar coordinates between 0 and 2 pi for theta. Okay, so in order to do this, we will need to first solve for r. And so step one, we want to find r. To find r, we would use r equals the square root of x squared plus y squared. And that is equal to, well, x is equal to negative 2, y is equal to 6 from the ordered pairs that we found from the Cartesian coordinates provided in the problem. So that would be negative 2 squared plus 6 squared. And then that would equal the square root of 40 plus 36. And that's equal to square root of 40. So this is the exact answer if we provided it into in with the radical, the square root. And if we were to plug this into our calculator, unless it was a perfect square, it is going to be irrational, and we cannot provide the exact value as requested. So in order to find the exact value, we'd leave it like this, but we can simplify this a bit. So the square root of 40 is equal to the square root of 4 times 10, and the square root of 4 is a perfect square, and that's 2 root 10. All right, so that's 2 root 10. Now we want to find, step 2, find theta. Okay, so if we wanted to find theta, we could use tangent of theta is equal to y over x. So that would be equal to 6 over negative 2, which is negative 3. And to use the reference, using the inverse tangent, we would have tangent of negative of 3. That is equal to theta, and that's the reference angle. Notice we're using positive 3 here, and that would give us, but keeping in mind that the point negative 2, 6 lies in quadrant 2. Notice, right? Negative 2, and then positive 6. That would put us in quadrant 2. So to make that adjustment, it wouldn't actually be straight up the inverse tangent of 3. We would have to find theta to be pi minus the inverse tangent of 3. And that ends up equaling approximately, and that is the exact solution, but it doesn't ask us to find the exact solution. So if it was the exact solution, this would be the solution. But since it doesn't ask us for the exact solution, we could put this into our calculator, and that will end up being 1.89 approximately, or a couple more decimals, 2.25, I guess. And yeah, so that either one. So, anyways, that's how you go about this problem to find r and theta, which are the polar coordinates given the Cartesian coordinate values. So, anyways, let me know if you have any questions. I'm more than happy to help. So, good luck in your studying.